Okay, I just have the prompt up here, and I'm going to draw it right here. So first we're going to talk about the membranes and pressures. So if you have your lungs, these are your lungs, you've got a cavity that goes around each one, and it connects to your ribs and then to your diaphragm, and that's called your pleural cavity. So the membrane directly on here is going to be your visceral pleura, this is going to be then your parietal pleura, and the space in between is your pleural cavity. Okay, so that's kind of what's happening right there. The pressure in here should always be negative. This negative pressure is acting as a suctioning pressure because naturally our lungs are like a rubber band and they're going to want to collapse in, and that is due to surface tension. So you have water molecules that are like lining this right here, and these molecules are forming hydrogen bonds with each other. So this bond right there, we'll do it in this teal, that's a hydrogen bond. So this hydrogen bond is making a surface, has surface tension, which is causing the lungs to want to collapse. There's also fibers along this called elastin. And those elastin fibers are like a spring coil, and so as they expand, they're going to want to collapse as well. So naturally, your lung really wants to collapse, but this pleural cavity creates this suctioning pressure. Okay, and explain how it makes ventilation possible. So there's something called your Boyle's law, which says that pressure and volume have an inverse relationship. So what happens is if you have this right here, so you inhale, we'll do inhalation. So if you inhale, you're going to have an increase in volume and so a decrease in pressure. And that's going to follow the same trend here in your lungs because they're connected. So if your pleural cavity moves, your lungs are going to follow with it. So then air is going to go from high to low and you're going to inhale. Okay, opposite of that is going to happen when you have your exhalation. For exhalation, you're going to have a decrease in your volume and therefore an increased pressure. And so then air is going to flow out. But again, in here, it's always negative. It's just going, if you had like a chart for inhalation and exhalation, you're going from like -2 to like -6, and then your volume would look like that. So one thing I did forget to mention over here is because this surface tension is causing our lungs to want to collapse, we're going to have something to have to come and break this bond, and that's going to be called surfactant. Surfactant is made by type 2 pneumocytes, and so surfactant is making, I think it's like it looks like that, it has a hydrophobic end, so it's going to come in and it's going to break these water molecules apart. Okay, so that's surfactant, and that is how, a lack of surfactant impairs this because then these hydrogen bonds are there, and if these hydrogen bonds are there, again, surface tension, that is going to decrease your compliance, but it's going to increase your elastance. So an example, this is like your respiratory lung disease, right? It's going to be harder to inhale because you've got these hydrogen bonds that are increasing the surface tension. A pneumothorax, this is usually positive, but say that you were to get like stabbed right here, if you were to get stabbed right there, right, then you're going to have air flowing in to here, and that's going to make it more positive. So then there's nothing suctioning the lung out, and so my lung is going to then collapse down. And so that's what pneumothorax is when you get a positive pressure right here, which is no longer causing the lung to go to the cavity. Okay, Laplace's law. So Laplace's law is going to be talking about it's pressure versus volume. And so it's basically just like the amount of pressure you need to change your volume. I don't know if that's the exact equation, but it's in relation to this compliance and elastance and how they're inversely related. Compliance is going to be how easy it is to inhale, to get air in, and then elastance is how easy it is, I guess, to push air out. And so if you have like an obstructive lung disease, then you're going to have decreased elastance because these fibers are broken, or you have a problem with your surfactant, so that's going to cause that to go down. Okay, I'm going to end this video and then we'll make another one.